Hello everyone and welcome to another episode of Let's Code Duke Nukem, where we aim to recreate the original EJ action platformer, released in 1991. In the previous episode, we managed to convert all tiles to images that we can use, so in this episode we will tackle parsing the levels and creating an image containing the full map of each level. We will focus on just converting the static elements of each level for now, so all the items, enemies, etc. will not show up until a later episode. Now the level format for Duke is fairly straightforward. All the numbers for each levels are just stored in a file, and each level is just a grid of 128 columns by 90 rows. And the data for each cell in the grid is just a number in the file. There's no compression or whatever, so we can just loop through these rows and columns and just read in these data. Now the people at the modding wiki, shikari.net, have figured this out for us, so shout out to them for figuring it out. And let's just get started. So we'll introduce our level class here, and let's just have our resource loader come up with a level. So we want to have the number of the level. Let's open up our random access file again. And we want to convert from our level number to the file name. So it's world AL and then .dn1. And then we want this number to be formatted hexadecimally. And we want to resolve this relatively to our base path, of course. Convert to file, open up for read mode. Catch the IO exception and rethrow a runtime exception. All right, so we said that each level has a width of 128 and a height of 90. So we just need to read in all these data. So let's just go ahead and create an array where we just store these numbers that are in the files. So we'll make a new int, and the size of this int is going to be the width times the height. And for now, we'll just loop through it and read them one by one. All right, so now the way that DOS stores these 2-byte variables is a bit different than how Java does it. Let's first just read 2 bytes. So in Java, a 2-byte variable is a short. However, the byte order in which these numbers are interpreted are different in Java, so we need to reverse those bytes. And we can assign it. So tiles I equals this here. So this loops across the entire file, reads each tile, and just let's return a new level with these tile data. So private int tiles. Let's create a constructor. Let's create a method, public int get tile int row int call. Return tiles row times width plus call. Alternatively, you could store a 2-dimensional array, but this should be fine as well. All right. So now that we have the level, let's just quickly write a function that converts this level to a buffered image so that we can see if we're doing it correctly. So this will be a throwaway function. Now we can read in let's call it tile set, and we need to have all the tiles that are in the back.dn1 files plus the solid.dn1 files. If we refer to the level format here, we can see that the tile mapping refers to these two files. Now there are a lot more tiles in the level, but for now we'll focus on the first set of tiles, the simple ones basically. Otherwise, you know, the rest are going to be the enemies and the items and stuff, and we'll leave that for later. So for now we'll just do the background tiles and the solid tiles. So we need to have back 0.dn1 back 1 back 2 back 3 and then solid 0 solid 1 2 and 3. So let's flat map, and let's call this name, and then we say read tiles name. Now the tiles in these tile sets, as we were doing the last episode, they have a header position for the amount of tiles that are in the file. However, these files usually contain more tiles than the original game actually uses. The original game assumes that there are 48 tiles in each file. So, and we need to respect that limitation, because otherwise the values that we're reading here while we read the level data are not going to correspond with the correct tiles. So, yeah, let's collect it all to a list. All right, so now we have the tile set of the background and solid tiles. Now let's create one big map, like a level map here. All right, so the width of the map is going to be the width of the level times 16, and the height is going to be the level height times 16, and we're going to have byte code ARGB. Return the map. Okay, row. Now the row refers to the height, and then the column spans the width. So if let's int tile ID equals level dot get tile at row column. If the tile ID is less than 3000, then we'll grab it from the tile set. We need to divide it by 32 according to the documentation here. Due to the way the tile graphics are stored, you need to divide it by 32. Okay. So we can say map.getGraphics.draw image. This guy, let's do, this is the X position, so that's call times 16. We need the Y position, that's row times 16. Don't need the observer. All right. So let's run, no, we of course need to save this image, so let's do that here in our main class. So let's do loader.read level 1. image IO dot write loader to image this level. And again PNG, and then we'll call it a level 1.png. Okay, so why is it not rendered image? Format. All right, new file. Yep. Okay. Let's run. Okay. Let's see what it came up with. And it's looking pretty good. Now you can see the gaps in the level. And this is where, special objects are located. Like, if I do remember correctly, an Acme sign is supposed to hang here. And like a robot is supposed to spawn here. So, yep. But all in all, here you can see the gaps even better, because these have like background tiles. So all kinds of items and stuff should be spawning here. Maybe it's nice to make a map for each level. So let's see, we have levels 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C. So we'll start at 1. And we need to go to D, smaller than D. So I guess smaller than or equal to C. I plus plus. And then instead of hard code number 1 here, we'll say, and let's just have the same type of formatting. So world AL %x dot PNG. Something like that. Okay, let's run it. Takes a while to warm up, I guess. Okay, so first level looking good. Second level is the intermission level. Cool. All right, small level here. Yep. Yeah, but it's looking pretty good. Looking pretty good. So the last level is just a showdown between Duke and Dr. Proton. So that concludes it for this episode. We can read the level data. We have made a small start with our level class here. And the resource loader is actually able to read the level and convert the level data into graphics. So next episode, I think we're well and ready to start working on the game loop. And we'll start to render the level and scroll about in the level as well. So thanks for watching and see you guys next time. Bye-bye.